Chapter 6. Physical and Chemical Changes. You will learn about physical changes, chemical changes, rusting of iron, crystallization. Introduction. Change is the law of nature. Every day you come across many changes in your surroundings. For example, stretching of rubber band, ripening of fruits, digestion of food, evaporation of water, rusting of iron, growth of plants and animals, etc. Out of all changes, some changes can be noticed immediately, some others take time, while remaining go unnoticed. Changes can be classified in many ways. One way to classify changes is to observe whether or not the change results in the formation of new compound. On the basis of this criterion, changes occurring in our surroundings are of two kinds: physical and chemical changes. Physical change. A change in which a substance undergoes changes only in its physical properties such as have, size, color and state, and no new substance is formed is called physical change. Physical changes are generally temporary and can be easily reversed, that is, they are reversible changes. Some common examples of physical changes are as follows: melting of ice, tearing of paper, freezing of water, boiling of water, dissolution of salt, sugar in water, glowing of an electric bulb, expansion and contraction of metals, breaking of a glass tumbler, stretching of rubber band, melting of candle wax, heating an iron nail. Let us perform some activities to understand the physical changes. Chemical changes. A change in which a substance undergoes changes in its physical and chemical properties is called a chemical change. During a chemical change, one or more new substances are formed which shows properties different from the original substance. These changes are permanent and cannot be reversed, that is, they are irreversible changes. Some common examples of chemical changes are as follows: burning of any substance such as candle, wood, paper, coal, petrol, LPG, etc. Formation of curd from milk or curding of milk, bursting of crackers, cooking of food, digestion of food, photosynthesis, rusting of iron, rotting of fruits and vegetables. Chemical changes are very important. A variety of new substances can be obtained as a result of chemical changes. For example, a lot of important compounds such as soaps, detergents, medicines and plastics are formed as a result of chemical changes. A chemical change is also called a chemical reaction. This initially presents substances that take part in a chemical reaction are called reactants. The substances that are formed as a result of a chemical reaction are called the products. In an equation, the reactants are written on the left hand side and the product on the right hand side. Reactants, products. If two or more reactants or products are featured in an equation, they are linked together by a plus sign. Reactant A plus reactant B, product X plus product Y. A chemical equation is the representation of a chemical reaction using the symbols and the formula of the substances involved in the reaction. Let us perform some activities and observe the corresponding chemical changes. In activities 3, 6, you saw that in each change, one or more new substances are formed. In addition to new products, the following characteristics may accompany a chemical change. Heat or light may be given off. In activity 3, the ash was a new substance formed when magnesium was burned. Also, there is evolution of light and heat, which indicates a chemical change. A change in color may take place. In activity 4, both iron sulfate and copper are new substances. Also, there is a change in color of the solution from blue to green, which indicates a chemical change. Sound may be produced. You know that bursting of firecrackers produces sound, heat and light. In activity 5, a hissing sound is produced when vinegar reacts with baking soda. Evolution of gas. In activity 5, carbon dioxide gas is evolved when vinegar reacts with baking soda. Also in activity 6, a pungent smell of sulfur dioxide gas is evolved. Formation of precipitate. Precipitate is a solid insoluble substance that deposits at the bottom in some chemical reactions on mixing two transparent solutions. In activity 4, there is a reddish brown deposit on the iron nail. Also an activity 5, insoluble white precipitate of calcium carbonate is formed. Rusting of iron. When an iron piece is left exposed into moist air, it chemically reacts with oxygen and water present in the air and form a reddish brown powdery substance. This reddish brown powdery substance is known as rust. Rust is not iron, rather it is hydrated form of iron oxide Fe2O3 into H2O, where the number of molecules of water is not fixed. 4Fe plus 3O2 plus H2O is 2Fe2O3 into H2O. Iron, oxygen, water, iron oxide, rust. The formation of rust on iron is called rusting of iron. That affects iron particles and slowly destroys them, leading to considerable loss. Rusting always takes place in the presence of both oxygen and water. Let us perform an activity to prove the above statement. Do you know the salt in water speeds up the process of rusting, which leads to huge loss to the shipping industry? Science fact: seawater can hold up to 35 grams of salt per liter. Prevention of rusting. There are some measures which can be used to prevent rusting of iron. By avoiding direct contact with air and moisture. The direct contact of iron surface with air and moisture can be avoided by using the following methods. Applying a coat of paint or grease on iron articles. These coats should be applied regularly to prevent rusting. A more efficient method is to coat the surface of iron article with another metal such as zinc. The process of depositing a layer of zinc on iron is called galvanization. The pipes used for supplying water in our homes are made of galvanized iron. By alloying, rusting can also be prevented by making alloys. An alloy is a mixture of a metal with another metal or other non-metal which enhance the properties of iron. As a result, it does not undergo rusting. Table 6.1 Important alloys and their uses. Alloys: brass. Composition: copper plus zinc. Uses: in making utensils. Bronze, copper plus tin in making coins and musical instruments. Stainless steel, iron plus nickel plus chromium in making pipes, pumps and surgical equipments. Crystallization. Closely observe common salt and sugar. You will find that all common salt and sugar particles are of uniform shape and size, that is, almost cubical. Such uniform structures are called crystals. The crystals of common salt, sugar, etc. are formed from the solutions of these substances by a process called crystallization. We obtain salt from seawater by the process of crystallization. Seawater is collected in large and shallow pits along the sea coast. The heat of the sun evaporates the water. Since water has a limited capacity for holding the dissolved salts, some of the salts crystallize out. The salt crystals so formed may include some impurities. Hence, they are dissolved in fresh water, filtered to remove the impurities and then again evaporated to obtain crystals of pure salt. Let us perform an activity 8 to understand crystallization. Key terms: physical change, a reversible change in which only the physical properties of a substance are changed and no new substance is formed. Chemical change, an irreversible change in which the physical as well as chemical properties of a substance changes. Rusting, the process in which a layer of reddish brown powder, hydrated iron oxide, is formed on iron articles when exposed to moist air. Galvanization, a process in which a layer of zinc is deposited on iron articles to prevent rusting. Alloy, a mixture of a metal with another metal or other non-metal. Crystallization, a process of obtaining used crystal of a substance from its solution. Quick recap. In a physical change, a substance undergoes changes only in its physical properties and no new substance is formed. In a chemical change, the physical properties as well as the chemical properties of the substance changes to form new substances with different properties. A chemical change is commonly accompanied by production of heat or light, a change in color, the evolution of gas, formation of precipitate, or the production of distinct sound or smell. The initially present substances that take part in a chemical reaction are called reactants and are written on the left hand side of the equation. The substances that are formed as a result of the chemical reaction are called products and are written on the right hand side of the equation. Rusting of iron takes place when an iron object is exposed to air and moisture. A reddish brown layer of hydrated iron oxide known as rust is formed. Rusting of iron can be prevented by applying paint or grease, by galvanization and by alloying. Pure crystal of some substances can be obtained from their solutions by process called crystallization. Chapter